in this example, or in these practice problems here, we are now going to go from representative particles to mass. So just the opposite way of the previous practice problem. Okay. So here we're starting with representative particles, molecules, atoms, or formula units based off of what the identity of your substance is. And then we're going to go all the way to grams. So the way that I would begin this is by starting with your representative particles, so 3.40 times 10 to the 22 molecules of H2O. And we want to get out of molecules and into moles. So I want 1 mole of water has Avogadro's number of water molecules in it. That way our molecules of water cancel. But I'm not done. If I'm in moles, I still want to get to grams. So I know that I can find the relationship between mass and the mole by using the molar mass of water. Okay, and so water is hydrogen and oxygen. Hydrogen has a molar mass of 1.01 grams per mole. Oxygen has a molar mass of 16 grams per mole. We've got 2 hydrogens, so 2.02 grams per mole, and 1 oxygen. So the molar mass is going to be 18.02 grams per mole for water. So there's 18.02 grams for every mole of water. Our moles cancel, and we're going to be left with grams of water. Okay, and we can plug this in our calculator now. So I'm going to take my numerator over here, 3.4 times 10 to the 22nd. And I'm going to divide it by Avogadro's number. Okay, get that answer and go ahead and multiply by the molar mass of water. And you get 1.02 grams of water here. Okay, so just about the mass of a paperclip has this many molecules of water in it. It's a bunch of molecules. All right. Here we've got atoms of bismuth, and so atoms tells me that bismuth is just an element. I also can tell by the formula here. Okay. Alright, so if we look here again at bismuth, we can start with the representative particles that they give us, so 6.02 times 10 to the 24th atoms of bismuth. And I want to get out of atoms and into moles, because moles is going to bridge me between mass and particles, or particles and mass. So I know that 1 mole of bismuth has Avogadro's number of bismuth atoms. And that will cancel out my atoms of bismuth and leave me in moles, but again I'm not done because I want mass. So I remember moles and mass are always related through molar mass. So I want 1 mole of bismuth on the denominator, so that way my moles of bismuth cancel. And I can use the molar mass from the periodic table for bismuth to get into grams. So if I find bismuth on the periodic table, I see that its molar mass is 208.98 grams per mole. Okay, all my units cancel. I'll be left in grams of bismuth. Okay, and now it's just plugging it in the calculator. So I've got 6.02 times 10 to the 24th. And I just want to go ahead and point this out ahead of time. They both have the same coefficient and are only different by 1 order of magnitude. So I'm guessing this is going to be 10, but we can go ahead and plug it in just to practice plugging stuff in the calculator. 6.02 times 10 to the 23rd for Avogadro's number. And what do you know? We get 10. Okay. Go ahead and multiply that by 208.98. And you should get 2089.8 grams of bismuth. Okay. And then for the last problem, let's go ahead and convert, oh, I lost my green marker, there it is, the number of formula units of potassium acetate into grams of potassium acetate. Okay. So here I'm going to go ahead and start with 5.63 times 10 to the 11th formula units of potassium acetate. And I'm going to go ahead and point out the reason it's formula units is because this is ionic. You've got a metal and a polyatomic ion. Okay, I want to get out of formula units and into moles, so I can use Avogadro's number to get out of my particles and into moles. All right, and then again, this is going to be formula units of potassium acetate. All right, that way my formula units cancel, and I'm left in moles. But again, I need to get to mass, so I need to multiply by molar mass. So I need to calculate the molar mass of potassium acetate. And I'm going to use a separate sheet of paper for that. So KC2H3O2, and there's 1 mole. Okay, so let's grab a sheet of paper and calculate the molar mass of potassium acetate. All right, so for molar mass, I've got potassium, carbon, hydrogen, and oxygen. I know oxygen is 16 grams per mole, and there's 2 oxygens in my formula. I know hydrogen is 1.01 grams per mole, and there are 3 hydrogens in my formula. I know that carbon is 12.01 grams per mole, and there are 2 carbons in my formula. So 24.02. And then potassium, if you look on the periodic table, you probably don't have this one memorized yet, is 39.10 if you round that up. Okay, so 39.10. And there's just one of them there. Okay, if I add this all up, I'm going to have the molar mass of my compound, potassium acetate. So we're going to do 39.1 plus 24.02 plus 3.03 plus 32. And so you should get 98.15 grams per mole. So I'm going to use that as my conversion factor up here. Okay, so my moles of potassium acetate cancel, and I'm going to be left in grams of potassium acetate. Sorry for running out of room. Go ahead and plug all this in. So I'm going to have 5.63 times 10 to the 11th formula units, all right, divided by Avogadro's number. Get that answer, and go ahead and multiply by 98.15. So we should get 9.18 times 10 to the negative 11th grams. So this is a very, very small amount, but that's also not a lot of formula units either. That's less than 1 mole. Okay.